All right, so let's jump right in. Picture this. About 400 years ago, a single book comes out that basically rewires the entire way humanity thinks. Seriously, it's called the Novum Organum, which means new instrument, by a guy named Francis Bacon. And his argument was as simple as it was revolutionary. The way we'd been trying to figure out the world for centuries, it was completely, fundamentally broken.
And Bacon kicks things off with a question that honestly feels more relevant today than ever. How can we be sure that what we know is actually true? How do we get past just arguing over the same old ideas and actually discover something new? For him, it wasn't that we were missing a few facts here and there. No, it was much worse. We were lost in a pitch-black room with no idea where the light switch was.
And he had this incredible way of putting it. He saw the so-called geniuses of his day as just fumbling around, bumping into furniture, and hoping they'd magically stumble upon the truth. Bacon's big idea wasn't just about finding the right road. It was about inventing the lantern that could light the way for everyone who came after him.
So what did this groping in the dark really mean? What was the problem he was trying to solve?
Well, for something like 2,000 years, the worlds of philosophy and science were basically stuck on repeat. Most thinking was dominated by the ancient logic of guys like Aristotle. Now, the method back then was to start with some big, grand theory, and then just find arguments that seemed to support it. But Bacon looked around and saw that this wasn't leading anywhere new. It was, as he put it, an endless cycle of repetitions. A ton of talk, a ton of debate, but very, very little actual discovery.
But here's where it gets really interesting. Bacon realized the problem wasn't just the method. The problem was us. He argued that our own minds come with these built-in glitches, these cognitive biases that warp our view of reality before we even get started. And he gave them this fantastic name, the Four Idols.
Okay, so let's unpack these because they're fascinating. First up, the idols of the tribe. Think of these as the bugs that come pre-installed in the human operating system. Our tendency to see patterns where there aren't any, or to let one really dramatic story completely shape our worldview. Then you've got the idols of the den. That's your own personal echo chamber. It's how your unique upbringing, your education, your habits, how all that stuff creates a little den that filters how you see the world. Third, the errors of our senses. Let's face it, our senses are pretty limited. We can't see ultraviolet light. We can't hear a dog whistle. They miss most of what's really going on. And finally, my favorite, our love of abstraction. This is our mental shortcut of jumping to a big, simple conclusion because, well, it's just easier than doing the hard work of looking at messy, complicated evidence.
So, if our minds are this flawed, if we're all walking around with these idols, how on earth do we ever discover anything true? Well, Bacon's answer was to build a new tool, a completely new method for thinking that could help us overcome these built-in biases. And this is the absolute game changer. The old way? You'd start with your big conclusion and then work backward, trying to make the facts fit. Bacon just completely flips that on its head. His new way, the inductive method, demands that you start with the evidence. You have to begin by making careful, systematic observations of the world around you, and only after you've gathered a ton of data do you slowly, cautiously build your way up to a general rule. No more jumping to the finish line. It's the difference between guessing in the dark and actually turning on the light to see the path ahead.
And what he lays out here, well, it's basically the blueprint for what we now call the scientific method. Step 1, collect all the data you can possibly find on something. Step 2, organize it. He had this system of tables, a table for where the thing you're studying is present, a table for where it's absent, and the table of how it varies. Step 3, and this is the magic right here, you use those tables to start excluding what it can't be. Then, whatever's left after that rigorous process of elimination, that's your likely conclusion. But you're not done. The final step is to test that conclusion with brand new experiments.
Now, I know this can all sound a bit abstract, so let's make it concrete. Let's see how Bacon himself put his own method to the test to answer a huge question. What exactly is heat?
So he started with his table of presence. He made a massive list of every single place he could find heat. You've got the obvious stuff, right? Like sunshine and fire. But then he includes things like boiling water, strong acids, even the heat you get from friction when a hammer strikes an anvil. He gathered a huge, diverse data set. Then came the table of absence, which is just as important. Here he listed things that seemed similar but didn't have heat. For example, the rays of the moon look like the rays of the sun, but they're not hot. A glowworm gives off light, but it isn't warm. This comparative data was absolutely crucial for what came next.
Okay, now for the really cool part, the process of elimination.
By comparing these two lists, he starts to systematically cross off possibilities. Since the sun causes heat, heat can't just be some earthly phenomenon. But wait, since there are underground fires, it can't be purely a celestial thing either. See how this works? Since water can be hot without being on fire, heat can't be the same thing as light or flame. And get this, a piece of hot iron weighs the same as a piece of cold iron. So heat can't be some physical stuff that's being added or taken away.
So after all that careful, systematic slicing away of what isn't true, what's left standing? What's the one thing that shows up in every single case of heat, from the sun to a hammered anvil, and is missing from all the cold things? Bacon's conclusion was, and I mean this, just mind-blowing for his time. Heat is a type of motion. A rapid, vibrating, expansive motion of the tiny little particles inside a body. He essentially figured out the kinetic theory of heat almost 200 years before it became mainstream science. It's just incredible.
And that brings us to the real why behind all of this. For Bacon, creating a new way to think wasn't just some fun intellectual puzzle. No, it had a much, much deeper purpose.
First off, he genuinely believed that the search for truth was one of the most noble things a human being could do. Just the act of trying to see the world as it really is, without all the fog of superstition and bias and confusion, he thought that was a beautiful and worthy goal all by itself.
But that wasn't the whole story. You probably heard the phrase, knowledge is power, right? Well, that was Bacon. But when he said it, he didn't mean power for a king to win a war or for a merchant to get rich. He meant power for all of humanity. The real goal of science for him was to understand nature so that we could relieve human suffering and improve life for everyone. It was about giving us power over nature so we could build a better, healthier, and more prosperous world.
And that really brings us right back to today, doesn't it? Bacon handed us this incredible toolkit to fight the biases of the 17th century. But what about our biases? In our world of social media feeds, filter bubbles, and constant information overload, what are the modern idols that are distorting our view of things? It's a 400-year-old question, and I'd say it's never been more important to ask.